Happy Easter, everybody! I'm playing with something I found in the recycling dumpster. It's a 16 terabyte helium-filled drive, which is from HP but manufactured by Seagate. And there is the original Seagate model number. If you want, you can look that up in the internet. Helium drive normally have a second enclosure to make them really helium tight, and this one is not laser welded like the most. It's something different. You can see here this mark, and that tells us it is stir welded. The correct term is friction stir welding, and that's an interesting process. You can see that here. There is a little pin that goes into the material like a drill. And then when the shoulder touches the material, it heats up, melts almost, and is stirred by the rotation and mixed together, and that produces a very stable weld. I hope to hear a little bit of hiss from the helium when I poke a hole into the outer shell, but there was nothing. So it seems the inner shell is tight enough for the helium and nothing has leaked into the outer shell. So let's see later how that works. These high-capacity drives are filled with helium because helium creates less turbulence when everything is spinning around. And that makes it possible to place platters closer together, to have more platters in a tighter space. And also the platters can be a little bit thinner than normal because there is less vibration, less turbulence, and yeah, that's the reason why they use helium. You may notice that the heads are parked outside of the discs, so when the discs spin up or down, the heads will never touch the disc surface. On older drives there was a dedicated landing zone on the discs, most times near the center of the disc where the speed was the lowest. But that created problems, especially when the disc was not used for a while. It was possible that the head stuck to the disc and the disc wouldn't spin up. So that's something you sometimes encounter with old disk drives. Here you can observe an interesting effect. I call it bearing memory. So this disk normally spins in counterclockwise direction, and if you spin it in clockwise direction, it goes much harder because it has always spun in one direction and somehow it remembers that spinning direction. I said the heads never touch the disks, but how is that possible? When the disks are rotating, air or helium gas in this case is moving along the disks, and the head carrier is lifting off like a Russian Ekranoplan, which you see in the photo right here. No, that's not Photoshop, that's a real thing. And the head will lift off, and there is a tiny gap between the disk and the head always. While I was looking for information about hard disks and how they work and which way around they spin, I found there is quite some confusion about how hard disk actually works. So one user asks, does the hard disk always spin in the same direction, or does it spin in the direction where the path is closest to the data it needs? So he assumed that the disk will change its direction according to what you want to read, and that is of course totally nonsense, because it takes a couple of seconds to spin up the disk, and if they would change their direction, that would be seek times in seconds instead of milli or microseconds. And another one pointed out that the reason that these disks are all spinning counterclockwise is because of the Coriolis effect in the northern hemisphere of the Earth. So no, that's certainly not the case, because most of the disks, especially in servers, are mounted vertically. So the Coriolis effect doesn't have any influence on that. And anyway, the effect would be so small you couldn't even measure that. No, the reason is because all the manufacturers have agreed to spin in the same direction, because all the heads are mounted on the same place. So, well, you could do it in the other way. You could place the heads in the other corner of the drive, spin clockwise, but it doesn't really matter, and it doesn't make any sense to change that. And here are some microscope images of the head assembly. You see the head carrier here. That's not the head, that's the head carrier. And the heads are here at the edge of the carrier, and you can also see there are several heads for one carrier. So I assume they write multiple tracks in one go without repositioning the head. That's pretty clever. That increases speed, especially if you have 16 terabytes of data to write. By the way, there is an interesting comparison between hard disk performance and real life. So just imagine a Boeing 747 jumbo jet flying at Mach 4, that's 4 times the speed of sound, in a distance of 2 meters to the ground. And the pilot is counting every piece of grass on the way. So that's about the performance of a read-write head. Today it's probably a little bit faster. That example was already from the 1990s. So yeah, it's pretty impressive what a hard disk actually does. Maybe you know, maybe you don't know, a hard drive spindle motor is a 3-phase AC motor. Some people would call it a brushless DC motor, but it's only a brushless DC motor when you attach a DC electronic driver to the motor. So without that driver, it's just a 3-phase AC motor. But I'm connecting an electronic motor driver here. It's a standard motor driver you find everywhere, AliExpress, wherever. in the RC playground. And let's see if that actually works and how fast it can turn. I'm using a 3S or 4S motor controller here, which is capable of delivering 30 amps. That's way too much because we only need 1 amp maybe at full speed because these motors are not so powerful. Of course, the combination of a strong motor driver and a relatively weak motor is not ideal, so I guess it can't sense the back EMF of the motor correctly, so I have to give it a little bit of push and at the beginning. Okay then, thanks for watching.